So today we are looking at our second lesson from the radicals unit, and we're going to convert between entire and mixed radicals. So just as a reminder, a factor is a number that divides evenly into another number. Alright, a prime factor is a factor that is also a prime number. So a factor that is also a prime number. If you forget what prime number is, it's a number that is only divisible by 1 in itself. So for example, 3, 5, 7, there's a lot of them. Okay, so I'm just going to go over two factoring methods. So if we have 84, personally I like the tree method, but I know some of you have different methods. So I have 84, I can divide by 2, and I get 42. Divide 42 by 2, and I get 21. I can divide 21 by 3 and 7, and these are all of my leaves. Okay, so this is one method of factoring. You might also do the ladder method. So if you start off with 84, you can divide 84 by 2, and you get 42. Divide 42 by 2, and we get 21. And 21 is divisible by 3 and 7. And then these are all of my prime factors, or my leaves. Okay, so we're going to need to use one of our two factoring methods to simplify radicals into their exact form. Okay, so we started looking at how to simplify radicals last lesson, but just as a recap, if I want to simplify this to an exact solution, I'm going to just do my tree method here, and I've got 140, and I can divide that by 2, and I'm left with 70. I can divide 70 by 2, and I'm left with 35. And 35 is divisible by 7 and 5. Okay, so I'm trying to simplify the square root of 140. So I'm going to look for some pairs, and I have a pair of 2's. The 5 and the 7 are what I'm going to refer to as my leftovers. Okay, they don't have a pair, and so they're my leftovers. And I can rewrite the square root of 140 as the square root of 4, so my pairs, multiplied by my leftovers, 35. Okay, so the 4 came from my pairs of 2's, my 35 came from my leftovers. And now using our exponent laws, remember from yesterday, I can split my root to the square root of 4 multiplied by the square root of 35. Okay, well I know the square root of 4 is equal to 2 times 35. And when we leave this in our solution form, we don't actually have to write this multiplication symbol. I can just write it as 2 root 35, and there's an implied multiplication that's happening there. Alright, let's do another one. So 810, okay, so this time if I do my step method, okay, so 810 is divisible by 2, and I'm left with 405. Well, 405 is divisible by 5, and if I do that, I'm left with 81. 81 is divisible by 3. If you forget why, you can add 8 plus 1 is 9, and 9 is divisible by 3, so I know that 81 is divisible by 3. And if I do that, I'm left with 27. 27 is divisible by 3, and I'm left with 9, and 9 is divisible by 3 and 3. Okay, so I'm trying to simplify. It's the square root of 810. So I'm looking for pairs. So I have no 2 pair, and I have no 5 pair. So those are going to be my leftovers. And I have a pair of 3's, and I have a second pair of 3's. Right, so I can rewrite this as the square root of 9 multiplied by 9. So again, I've got my pairs here, and my leftovers are 10. Okay, so my leftovers are in green. Well, I can split this so I have the square root of 9 multiplied by the square root of 9 multiplied by the square root of 10, and the square root of 9 is equal to 3 multiplied by the square root of 9, which is equal to 3 multiplied by the square root of 10. So my answer is just 9 root 10. I haven't written the multiplication symbol because this is an implied multiplication. Okay, so I read that as 9 multiplied by the square root of 10. All right, let's do a cubed root. Okay, so cubed root is meaning I'm looking for triples. Okay, so I'm looking for triples. Okay, so if I do my tree, actually let's do the step ladder here. So we've got 1080, and if I divide that by 2 because it's even, I'm left with 540. If I divide this by 2, I'm left with 270. 270 again is divisible by 2, and I'm left with 135. 135 is divisible by 5, and I get 27 left over there. I can divide this by 3, and I get 9, and 9 is divisible by 3 and 3. Okay, so I'm doing a cubed root. So this time I'm looking for a number multiplied by itself 3 times. So I have 2 times 2 times 2 here. I have 3 multiplied by 3 multiplied by here 3 times. And then I have a lone 5. Okay, so my 5 is going to be my leftovers. Alright, so if I rewrite this, don't forget your little cubed root there. I get 2 times 2 times 2 is 8. Okay, so this is my triple there. And 3 times 3 times 3 is 27. So I have my triple there. And my leftovers multiplied by 5. Alright, well I can split this using my exponent laws. So I can rewrite this as the cubed root of 8 multiplied by the cubed root of 27 multiplied by the cubed root of 5. And we know that the cubed root of 8, so what number multiplied by itself 3 times equals 5 is 2. Sorry, I think I said that wrong. What number multiplied by itself 3 times equals 8 is 2. And the cubed root of 27, so what number multiplied by itself 3 times equals 27? Well, that would be 3. And my leftovers I can't simplify. So here I'm left with 6 cubed root 5. And I don't need a little multiplication symbol in between the 6 and the root 5 and the cubed root of 5 because it's an implied multiplication there. Alright, so question number 4 says the cubed root of negative 108. Now last time we were talking about this. So if I have an even root of a negative number, then we call it imaginary or non-real. And we can't do anything. But if we have an odd root, so cubed root, 5th root, 7th root, 9th root, as long as it's odd of a negative number, then we can solve. Because a negative number multiplied by itself an odd number of times is going to be negative. So really I'm just looking at, I can bring my negative outside and I'm left with 108. Okay, so I just have to factor 108, and I can say 108 is divisible by 2, and that would be 54 times, and 54 is divisible by 2, and that would be 27, and 27 is divisible by 3, and 9, and 3, and 3. So I'm looking for, it's a cubed root, so I'm looking for 3's. I've got a 3 multiplied by 3 multiplied by 3. And then I have 2 times 2. I don't have 3 of them, so these are going to be my leftovers. Alright, so I can rewrite this as the negative cubed root of my leftovers are 4, and my triple is 27. Okay, so I got this from 3 times 3 times 3, and I got this from my leftovers. And then I can rewrite this as negative cubed root of 27 multiplied by the cubed root of 4 which is just equal to negative 3, the cubed root of 4. Okay, and be really careful with the negative. I'm not going to put a negative anywhere else. It's just one negative. The number is negative. Okay, so when you're splitting that, just be very careful. The solution is going to be negative. The negative can come out because it's an odd root. All right, so we also want to be able to convert backwards. Okay, so what if I have a mixed radical? So when it's in this form, we call this a mixed radical. And now I actually want to put it back into an entire radical. So an entire radical, just to be specific, is this, for example. We would call this an entire radical. Okay. So the way I'm looking at this is, okay, I've got a square root. Okay, so how can I get, I've already got the root 2 in a radical. So I'm really just going to look at the 2. Okay, so it's a square root. So I want to know, this is my root 2, nothing's happening with that. How can I get a 2 back into the square root? Okay, so it came out of a square root. So it must be a number multiplied by itself twice to equal, or that number multiplied by itself twice. So really, because it's a square root, all I'm doing is doing 2 times 2. Okay, which means that this is just equal to the square root of 4 multiplied by the square root of 2. And now I can use my reverse exponent laws and say, okay, well, I can put them under 1. Just as before I split them, I can go backwards, which means that this is the square root of 8. Okay, and so all I did here is I thought, okay, well, how do I get 2 into a radical? Well, it's a square root. Okay, we don't have to write the square there. We know what, if there's nothing there, it's a square root. If I'm trying to get it back in here, then it's that number multiplied by itself. Okay, and that's how I got the 4. Let's do another one. Okay, so here right now I have the 3 multiplied by the cubed root of 5. Okay, I'm trying to get both of them into a cubed root. Right now I have already got this here, but I want to know, how do I get from the cubed root, from a 3 into a cubed root? Well, it had to have been something multiplied by itself 3 times inside of there to get 3. So all I'm going to do is, well, it's a cubed root, so it's just 3 times 3 times 3, which is equal to 27. And you can check that, right? 27, the cubed root of 27 is equal to 3. So I've done that right so far. And then I can say, okay, well, using my reverse laws, I can say the cubed root of 27 multiplied by 5. Okay, so my solution is the cubed root of 135. So the whole procedure here, we were looking at, how do I take this number that is outside of my cubed root and go back into a cubed root? Well, because it's a cubed root, it's that number multiplied by itself 3 times to get back into the root. And that is all.